The time travel paradox. Can we go back and change the past? What if you could go back in time and change one decision? Imagine waking up tomorrow, but everything is different. The city streets are unfamiliar. The people you know don't recognize you. The world has changed, subtly at first, then drastically. It's as if one moment in the past has shifted, sending ripples through time itself. But is it possible? Could we actually go back and rewrite history? And if we could, should we? For centuries, time travel has been the subject of myths, science fiction, and bold scientific theories. From the great minds of Einstein and Hawking, to the paradoxes that defy logic, and the quantum mysteries that hint at hidden possibilities. Today, we're unraveling one of the greatest mysteries of all time. Welcome to the time travel paradox, where science meets the impossible. The time travel paradox. Can we go back and change the past? The science of time travel. Before we can talk about changing the past, we need to ask a simpler question. Is time travel even possible?
Initiating launch sequence.
The answer? Yes. At least, when it comes to traveling into the future. According to Albert Einstein's theory of relativity, time is not constant. It's flexible. It stretches and bends depending on speed and gravity. This means that the faster you move, the slower time flows for you relative to someone standing still. This effect is called time dilation. And it's not just theory, it's been proven. Proof that time travel to the future works. Don't believe time travel is real? We've already done it. In 1971, physicists Joseph Haffel and Richard Keating put atomic clocks on a jet and flew them around the world. When they landed, the clocks had shifted. They were ticking slightly slower than the clocks that stayed on Earth. This wasn't an accident. Astronauts on the International Space Station experienced the same thing. Because they move faster than us, time runs slower for them. When they return to Earth, they've aged a little less than the people they left behind. Astronauts have already time-traveled into the future by milliseconds. But what if we took this further? What if you boarded a spaceship and travelled at 99.9% the speed of light? A one-year journey for you could mean decades have passed on Earth. If you travelled for long enough, you could return to Earth hundreds, even thousands of years into the future. Time travel to the future is not science fiction. It's physics. What about the past? But what about going back in time? This is where things get complicated. Physics doesn't forbid it, but every theory that allows for past time travel comes with paradoxes, problems that could break logic itself. Some physicists believe wormholes, theoretical shortcuts through space and time, could be used as time machines. Others suggest spinning black holes or cosmic strings might provide a way to bend time backward. But so far, every idea for travelling to the past comes with a catch. A problem so big that it might make past time travel impossible. A paradox. Next, the grandfather paradox, and why changing the past might be impossible. The grandfather paradox and changing the past. We know that travelling to the future is possible. But what about the past? Could you step into a time machine, go back 50 years, and change history? At first it seems simple. You go back, make a small change, and return to a world that's different. But there's a problem. A paradox so famous, it has become the ultimate argument against past time travel. It's called the grandfather paradox. What is the grandfather paradox? Imagine this. You travel back in time to the year 1930. You find a young man, your grandfather, before he ever met your grandmother. Now, you make a terrible decision. You stop him from meeting her. Without that meeting, your father is never born. And if your father never existed, neither did you. But wait, if you were never born, who went back in time to stop your grandfather? This logical contradiction is what makes the grandfather paradox one of the biggest problems with time travel. It breaks cause and effect. It suggests that changing the past is impossible. But could there be a way around it? Possible solutions to the grandfather paradox. Some physicists believe the universe has a way to protect itself from paradoxes. Here are 3 possible solutions. The self-consistency principle. Physicist Igor Novikov proposed that history is fixed. That means, even if you travel back in time, you can't change anything. If you attempt to alter history, something will stop you. Maybe the gun jams. Maybe you trip and fall. Maybe you decide against it at the last second. One way or another, history stays the same. The universe prevents paradoxes before they happen. The multiverse theory. Many timelines, many histories. But what if you really did change the past? The multiverse theory says, you didn't erase your reality. Instead, you created a new one. In one universe, your grandfather meets your grandmother. In the new universe, he never does. You still exist, but in the original timeline you left behind. Your actions don't erase history, they simply create a new version of it. The quantum solution. Time travel at the smallest scale. The final possibility. Quantum mechanics. At the smallest scale, particles behave strangely. Some theories suggest particles might travel backward in time without violating physics. This raises a question. If particles can do it, could we? Some physicists believe time travel could be possible in a way that doesn't break logic. Maybe it's not about changing our history, but about interacting with the past in subtle, indirect ways. Why changing the past is so dangerous. Even if time travel to the past were possible, should we ever use it? Changing one small detail could alter everything. The butterfly effect shows us that small changes can have massive, unpredictable consequences. If we prevent a tragedy, could we accidentally cause a worse one? Would time travel be a gift or a curse? Closing thought. Can we really change the past? So, can we go back in time and rewrite history? Maybe. But physics suggests that if we could, it would come with strict limitations or impossible consequences. Whether it's the self-consistency principle, multiverse theory, or quantum mechanics, one thing is clear. The past is more complex than we ever imagined. The future of time travel and what comes next. So far, we've explored what's possible and what might be impossible. But now, let's look ahead. Because time travel isn't just science fiction anymore. Right now, Scientists are pushing the boundaries of physics, quantum mechanics, and space-time itself. And they may be closer than ever to unlocking the secrets of time travel. What if time travel becomes a reality? Wormholes, theoretical time machines. For decades, physicists have speculated about wormholes, hypothetical shortcuts through space-time. According to Einstein's equations, a wormhole could, in theory, connect two distant points in time and space. A natural time machine, if we could find or create one. The problem? Wormholes might collapse instantly. They require exotic matter, something we've never observed. They could lead to uncontrollable paradoxes. Still, some scientists believe wormholes could be stabilized. If that happens, it could open an entirely new era of time exploration. Could we step into a wormhole and walk into the past? Quantum time travel, a new frontier. But maybe, the key to time travel isn't in space, it's in the quantum world. Right now, physicists studying quantum mechanics have found strange clues that suggest time might not work the way we think. Key discoveries. Quantum entanglement, where two particles influence each other instantly, even across vast distances. Quantum superposition, where particles exist in multiple states at once. Quantum time loops, where particles may, in some experiments, affect their past states. Could we harness these effects to send information, or even people, through time? Some theories suggest that quantum particles could travel backward in time without causing paradoxes. If so, could our consciousness one day do the same? The time travel experiments happening right now. You might think time travel is purely theoretical, but right now, experiments are happening. 2020. Physicists simulated a form of time travel using quantum computers. 2022. Experiments with quantum particles suggested they could reverse their state momentarily. 2024. Ongoing studies in entangled particles could hold the key to future breakthroughs. Right now, we're just scratching the surface. But these small steps could one day lead to something bigger. Could we see a real time machine in our lifetime? The dangers of time travel. But let's say we figure it out. Let's say we build a time machine. What happens next? Potential risks. If we alter history, could we destroy the future? Who controls time travel? Governments, corporations, individuals? Could criminals exploit time travel for dangerous purposes? If time travel becomes real, it might be the most powerful technology in history. But who decides how it's used? Could changing one event, one tiny detail, lead to disaster? Or could it be the key to solving humanity's greatest problems? What happens next? One thing is certain. Time travel is no longer just a fantasy. In the next few decades, new discoveries in quantum physics, space travel, and AI I may bring us closer to breaking the barriers of time itself. But whether we should is another question. If you had the chance to travel through time, would you? And if so, where would you go? We've travelled through the depths of physics, paradoxes, and possibilities. We've seen what's real, what's theory, and what's still a mystery. But now, the final question remains. What does time travel mean for us? What is the true nature of time? Are we already time travelers? The truth is, we are already moving through time. Right now. Every second, every breath, every heartbeat, time is carrying us forward. It may not be as dramatic as stepping into a glowing time machine, but make no mistake. We are all travelling through time, just 1 second at a time. And maybe that's the real secret. Maybe we don't need a time machine. Because every moment we live is already a moment that will never come again. The illusion of the past and future. We think of time as a line, past, present, future. But some physicists suggest it's all happening at once. That time isn't moving forward, we just experience it that way. Could this mean the past, present, and future all coexist? Could every version of you, past, present, and future, already exist side by side? If that's true, then maybe time travel isn't about machines or wormholes. Maybe time travel is already happening, within us. Should we ever change the past? Even if we could go back in time? Should we? Would we rewrite history to prevent tragedies? Would we erase mistakes, knowing the consequences are unknown? Would we risk creating something worse? Because no matter what we do, one thing will always remain true. The past made us who we are. Maybe our mission isn't to change the past. Maybe it's to learn from it. The future of time travel, will it ever happen? So, will humans ever master time travel? Maybe. We've already bent time with relativity. We've played with time on a quantum level. And we've imagined time travel in every culture for centuries. Whether time travel becomes a reality or stays a dream, one thing is certain: our future is unwritten. The choices we make today are the history of tomorrow, and that's the greatest power of all. So here's my final question to you. What if this moment, right now, is the only time you ever get? What if time isn't something to escape, but something to embrace? Because whether we can change the past or not, one thing will always be true. Time is the most valuable thing we have. Thank you for joining us on this journey through time. If you enjoyed this deep dive, don't forget to like this video, subscribe for more mind-blowing science content, comment below, if you had a time machine, where would you go? Watch more episodes on space, science, and the mysteries of the universe.